Lasers have a unique and fascinating property. Unlike other sources of light, laser beams don't appear to spread out or diminish in intensity. If you shine a laser on a wall, you get a small bright dot that doesn't get bigger or dimmer when you move away from the wall. This is quite unlike a flashlight, where you can visibly observe the illuminated area getting larger and dimmer when you move away from the wall. Why don't laser beams spread out? Well, that's the question I'm going to answer in this video. To begin, let's clear up a misconception. Laser light does in fact spread out, just like light from any other source. You can see that if I place a laser beam parallel to the wall, some of the light is spreading to the wall next to it. However, it doesn't spread out as quickly, and most of the light ends up on a concentrated spot. Nevertheless, the question posed at the beginning is still valid. Why does light from a laser spread out less than light from a regular light source? After all, a laser is just light, which is ultimately an electromagnetic wave. To answer this question, let's first take a look at the simplest source of light, the point light source. This light source emits waves with equal amplitude in all directions. As you can tell from this simulation, the waves decrease in intensity, which is depicted by the brightness of the color the further away they get from the point source. The same thing happens in reality. The intensity of light decreases as you move away from a light source. This happens because the waves are emitted radially in all directions and form circular bands that travel away from the point source, which progressively increase in diameter as they move away. This means that the same total light intensity is now spread out over a larger area, resulting in a lower intensity per unit area. This doesn't only happen with electromagnetic waves, but any kind of wave that emanates from a single point. Increasing the intensity of the light source doesn't stop the light from spreading out, it just makes the light brighter. The only way to stop the light from getting dimmer with distance is to change how the waves are emitted. So now we've established that a point light source emits waves in all directions, which causes the light to spread out and decrease in intensity with distance. Now let's see what happens when we add a few more point sources. The amplitude of the emitted waves no longer decreases uniformly around the point sources. The waves are brightest to the left and right of the point sources and dimmest above and below them. Moreover, the waves no longer spread out uniformly in a circle away from the point sources, but instead form vertical bands that are parallel to the line connecting the point sources. This happens because the waves of the different point sources interfere constructively. When two waves overlap in space, their amplitudes are added together. When a peak of one wave overlaps with the peak of another wave, the amplitude in the overlapping region is larger than the amplitude of the surrounding regions, thus making the region brighter. This is called constructive interference. On the other hand, when the peak of one wave overlaps with the trough of another wave, the two cancel each other out, resulting in an amplitude of 0 along the overlapping region, which makes it dimmer than the surrounding regions. This is called destructive interference. You can see that constructive interference is occurring at regions that are equidistant from the point sources. This is because at these points, the waves from all the point sources have the same amplitude and phase. Notice that the waves of the point sources are adding up together and starting to form a directed beam that doesn't spread out as rapidly. This only happens when the individual point sources behave as one coherent source, meaning they oscillate with the same frequency and are in phase with each other. So what happens if the point sources are out of phase with each other? Let's try it. We can no longer see a directed beam of light. The waves from each point source spread out radially as we saw with a single point source. That's because the waves no longer interfere constructively to form a beam. If you think about it, this is what we would expect. If we put multiple light bulbs next to each other, we don't suddenly end up with a laser beam. That's because it's highly unlikely that the light bulbs all have the exact same frequency and phase. Now that we know that we can create a beam with multiple coherent point light sources, let's increase the number of point sources to form a continuous line. The waves now form a bright beam traveling to the right. Notice that the intensity of the beam barely decreases with distance. The wave peaks on the right of the screen are almost the same color as those directly in front of the source. Also, the width of the beam is just as wide near the source as it is near the right side of the screen. This beam behaves a lot like a laser. In fact, this is what a laser beam is. We can conceptually think of a laser beam as being made of many point light sources that are in phase with each other. This explains why laser beams don't spread out as rapidly as point light sources. However, it doesn't explain why light from regular light sources spreads out more rapidly than laser beams. After all, most light sources aren't point sources of light either. In fact, most light sources are far wider than a laser, yet the light still spreads out rapidly as though they are point sources. Remember that we can conceptually think of a laser beam as being made up of multiple point light sources, and that in order for the beam to form, these point sources must be in phase with each other. This makes a laser a coherent light source. Regular light sources can also be conceptualized as being made up of multiple point sources. However, these sources differ in frequency slightly and are out of phase with each other. This makes regular light sources incoherent, and thus they cannot form a directed beam. To summarize what we've learned today, laser beams don't spread out as quickly as regular light because they are coherent. This means they emit light that has a uniform frequency and phase. On the other hand, regular light sources are incoherent. As a result, the light they emit cannot form a concentrated beam. Thank you for watching. I hope this video has given you an intuitive idea for why laser beams don't spread out as quickly as regular light.